Welcome to the chapter Matter Around Us.
This slide presents the overview of the chapter.
States of matter. Water can be found in all three states. Because of this, we can say that solids, liquids, and gases are three different states of matter. Click each image to learn more. Solids have a certain size, shape, and volume. In this state, the constituent particles are closely, regularly, and tightly packed. In the same way, the particles cannot move around much, but these particles only vibrate in fixed positions. Liquids have a definite volume but no definite shape. In this state, the constituent particles are not together closely. For example, milk is a liquid matter. It has a size or volume. Volume means it takes up space. But milk does not have a definite shape. It takes the shape of its container. Gases have neither a definite shape nor a definite volume. In this state, the constituent particles are far apart and move freely. Now, let us perform an activity to understand the compressibility of different materials. Click each tab to know more. Take a 100 ml syringe. Draw the piston to suck in air. Put your finger on the nozzle. Now press the piston. Observe the depth to which piston moves into the syringe. Repeat the same procedure with water and sand. Similarly, observe the depth to which piston moves into the syringe. From the above observations, we find that gases are highly compressible as compared to liquids and solids. We learned that mostly gases are used for cooking, LPG, and in many automobiles. In all these purposes, large volume of gas is compressed into cylinders of small volume to make them portable. Can matter change its state? We all know from our observation that water exists in the three states of matter: solids as ice, liquids as the water, and gases as water vapor. We must have seen many other materials that can exist in different states. For example, coconut oil is usually liquid in state, but if the weather is too cold, it becomes solid. Similarly, camphor is a solid, but if we leave it in the open air for some time, it changes to gas. Solids, liquids, and gases are the different states of matter. But the properties of matter are different in different states. This is because all matter is made up of very tiny particles. Let us do some activities to know about these particles and their arrangement in their various forms. Diffusion of matter. The intermixing of particles of two or more different substances on their own is called diffusion. In the incense stick activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread across the room. The rate of diffusion of gases is very high because the particles of gases travel with high speed. Rate of diffusion of gases is higher than the liquids, while the rate of diffusion of liquids is higher than solids. There are two reasons for the higher rate of diffusion of gases. One is due to the higher speed of gas particles and another due to the greater space between them. Similarly, the liquids have greater diffusion rate than solids because particles in liquids move freely and have greater space between them when compared to particles of solids. The screen shows the difference in arrangement of particles in solids, liquids and gases. The diffusion of solid into another solid substance is negligible due to the immobility of particles in solids. The diffusion of a liquid into another liquid and that of a solid into a liquid is much slower than the diffusion of gas into another gas. The following table shows the comparison of the properties of solids, liquids and gases. Let us know some important definitions. The following tabs give the information about the latent heat of fusion, latent heat of vaporization, and anomalous expansion of water. Click each tab to know more. Heat required to convert 1 gram of solid, that is ice, completely into liquid at a constant temperature is called latent heat of fusion. Consider a solid of mass, that is m, which converts from the solid phase to liquid phase when heat, that is Q, is supplied to it. The heat required to convert gram of solid into liquid is Q by m. Latent heat of fusion L is equal to Q by m. The value of latent heat of fusion of ice is 80 calorie per gram. Heat required to change 1 gram of liquid, that is water, to gas at constant temperature is called latent heat of vaporization. Assume a liquid of mass as m requires heat Q calories to convert its state phase of liquid to phase of gas. Then latent heat of vaporization is given by the expression Q by m and is denoted as L. SI unit and CGS unit of latent heat of vaporization is Joule per kilogram and calorie per gram respectively. A liquid usually expands when it is heated, but water behaves differently. Between 0 degrees centigrade to 4 degrees centigrade, its volume shrinks. Same amount of water in solid ice occupies more volume than liquid water. We say that water expands, increases in volume on freezing from 4 degrees centigrade to 0 degrees centigrade. This is an anomalous expansion of water. The density of ice is less than that of water, and this explains why ice floats on water. Here, let us perform an activity to know the effect of wind speed on evaporation. Click each tab to know more. Take a small amount of spirit in a cup. Pour a few drops on your palm. Observe the changes. Once again, take a few drops of spirit, say 1 ml, and pour the drops into 2 petri dishes individually. Generally, the petri dishes are shallow glass or plastic cylindrical lidded dishes used in the laboratory. Place both the dishes under a ceiling fan and switch it on. Close the lid of one dish. After 5 minutes, check the quantity of spirit in both the dishes. In this activity, we observe that the spirit disappears in the dish kept under the ceiling fan. At the same time, some quantity of spirit can be found in the dish which is closed. Finally, we learned that evaporation is a surface phenomena. During evaporation process, the particles escape from the surface of liquid. The increase in the surface area provides more scope for particles to escape from the surface, and this increases the rate of evaporation. The phenomena of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Humidity is another factor that affects evaporation. The amount of water present in air is called humidity. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water vapor is high in air, the rate of evaporation will decrease. So clothes dry slowly during rainy season but fast on a sunny and windy day. Because of increase in wind speed, water vapor particles move away with the wind, decreasing the amount of water vapor in the surroundings. When we work, the body produces heat. This increases the temperature of the skin. As a result, water presents in the sweat glands. The particles of liquid absorbs energy required for evaporation from our body and escape to the surroundings. This makes us to feel cool.
Knowledge check. Attempt the following questions to check your understanding. Knowledge check. Attempt the following questions to check your understanding. Knowledge check. Attempt the following questions to check your understanding.
Now, let us do a sample drag and drop exercise to check your understanding. Put the following objects in the correct box. In physics, A state of matter is one of the distinct forms that matter takes on. Each of the states is also known as a phase. Elements and compounds can move from one phase to another when specific physical conditions change. Drag the labels which suit into appropriate groups and click Submit button to verify the answers. The state of the matter refers to the group of matter with the same properties.
Read the questions and attempt the answers on your own. You can click Answer for your reference.
Follow-up work. Prepare a model to demonstrate movement of particles in solids, liquids and gases. Suggest an activity which provides the evidence for the motion of particles, attraction between particles and interparticle space.
Test your understanding of the chapter by taking the mock unit test